Dear students, in this video we are going to see chapter 3, it is Boolean algebra. Okay. Now, what is Boolean algebra? In Boolean algebra, a variable is a symbol used to represent an action, a condition or data. A single variable can only have a value of 1 or 0. Okay. 1 corresponds T and 0 corresponds F. 1 corresponds true, that is T, 0 corresponds false, that is F. These red color marks we are using in logical expression. That's why these are called logical operators. This T, F, see this complement, this or disjunction, this is called and or conjunction. These all red color marks we will use in logical expressions. That's why these are all called logical operators. Okay. Here 1, 0, these symbols are called the Boolean operators. Okay. Now we'll see one by one. The complement represents the inverse of a variable and is indicated with an over bar. Over bar means this. See, the complement of A is A bar. Okay. A literal is a variable or its complement. Okay. Here we can use this word for variable. Okay. Now addition is equivalent to the or. Addition is equivalent to the or. Or we can say, we can denote plus also for addition. Okay. In Boolean expression. Now in Boolean expression we can put this bar for the complement. Okay. In Boolean expressions we put or plus. Okay. In Boolean algebra we use and for the multiplication. Okay. Or this dot represents multiplication in Boolean expressions. Okay. Now see this example. What are the values of the A, B and C is the product term of A dot B complement dot C complement. Actually this is B complement and this is C complement is equal to 1. See, A dot B complement dot C complement is equal to 1. Now we have to see, we have to find what are the values of A, B and C if this condition is true, if this product is true. Okay. Each literal or we can say even variable. Okay. So each variable must 1. Then only the product must be 1. Okay. So that here A dot B complement. So B complement must be 1. Therefore, what is B? B is equal to 0 because B complement is 1. Okay. Now C complement should be 1. So definitely C is 0. Okay. So what is A? A must be 1. Then only we can get A dot B complement dot C complement is equal to 1. Okay. That's it. Now we see few Boolean identities or we can say Boolean laws. Okay. Now you see here we have different Boolean identities or Boolean laws for the operator and or. Okay. And is nothing but conjunction, or is nothing but disjunction. And we can say and or this product. Okay. This or we can say this is plus. Okay. Okay. Now the first one is identity law. See, this is the and form, this is the or form. And then null law or we can say dominance law. This is and form, this is or form. Then idempotent law. Okay. Then inverse law. Then commutative law and associative law, distributive law, absorption law, De Morgan's law, finally double complement law. Okay, all these are Boolean laws or we can say Boolean identity. Okay. All these laws are true. Suppose if you want to check, you can check through truth table. That's what we are going to see further. How to prove through truth table, how to prove using the Boolean identities, or how to find the all possible values of the Boolean function, or how to simplify the given Boolean function, we are going to see one by one. Okay, by using this law, you see another one, the duality. What is duality? The dual of a Boolean algebra expression is obtained by interchanging the rules of dot and plus, and also interchanging the rules of 0 and 1. Interchanging means, you see, wherever we have dot, we have to put plus. Wherever we have 0, we have to put 1. Vice versa. Now, see the example. The dual of a plus b multiply c bar or c dash. This is complement of c plus 1. What is the dual form of this expression? That is, you see here, a b plus c complement dot 0. Why? You see here in between a and b you have plus. So what you have to do? If you have plus, you have to replace by dot. If you have dot, you have to replace by plus. So now I have plus here, so I replace by the product. This is here. Now, so that it will become like AB. Okay. Here multiply. Okay. See, here one term, multiply here one term. So that this is here the product. So that I am putting plus. Okay, for this place. Okay. Now here C complement plus 1. So I have to replace this plus by product. Okay. So C complement product 0. Why? Because 1 has to be replaced by 0. So this is the dual form of the given expression. Okay. What the theorem says here, for every true equality in Boolean algebra, the dual of that property is also true. Yes. Even you can verify this through truth table for any Boolean algebra expression. Okay. Now we'll see what is Boolean function. Now you see there are 2 to the power n different Boolean functions of degree n. Okay. Suppose we have n variables. You see, with n variables there are 2 power n different n tuples. Okay, of zeros and ones. Okay, this we know that. See, suppose I have 3 variables, then 2 power 3, 8 different 3 tuples. Okay, we will have in the function. But here, what we are discussing, see, 2 to the power n different Boolean functions we can create from n variables. Suppose here 3 variables, then 2 to the power 3. So 2 to the power 3, 8. 2 to the power 8, how much? 256. Okay. So 256 different functions you can create from 3 variables. Okay. Now see, these are the examples. Okay. Now Boolean expressions and functions. Okay. Now what we are going to do hereafter, we are going to find the all possible values of the Boolean function and simplification of the Boolean function, and how to prove the given expression by truth table, how to prove the given expression by the Boolean identities or Boolean laws. These are the things we are going to find. We are going to see one by one. Okay. Now you see this example. Find the values of the Boolean function. Okay. This is a given function. Okay. Now we are going to find the all values of the given function here. Okay. Now how many variables here? 1, 2, 3. 3 variables. Here 3 variables. Okay. Now you see here. See this point, the first point. With n variables, there are 2 power n different n tuples. Okay. Now here n is 3 in the question, in the example 3. So 2 power 3 is 8. So different 3 tuples. See, 2 power 3 different 3 tuples. That means 8 different 3 tuples. Okay. Of zeros and ones. You see here. 8 different 3 tuples of zeros and ones. You see here. You see first 3 columns. You see here 3 variables. X, Y, Z is a variable. But here in the function we have the term Z bar, complement of Z. Okay. But the variables are 3. Okay. Now X, Y is a 3 variables. Now you see here. See the first row. Second, third, fourth, fifth, sixth, 7th, 8th. So 8 different 3 tuples we have for 3 variables. Okay, this is what we are discussing here. Okay, this is what we are discussing in the first part. Okay, so now we have to list all this. This already you have studied in I think analog system or some course in your engineering field, but here, okay, I can explain. You see here, the first combination is 0, 0, 0. Next you see 0, 0, 1, then 10, 11, 100, 101, 110, 111. Okay, these are the 8 different 3 tuples for 3 variables. Okay, this you have to list first. Then you see in the function what I have xy. Okay, this is the total expression, but here the first part is xy, which means you have to do the product of these two possibilities, these two tuples. Okay, so now 1 1 multiply 1, so 1 1 multiply 1, so 1 multiply 0 0, so 1 multiply 0 0, so 0 multiply 1 0, 0 multiply 1 0, 0 0 0, 0 0 0, like that you can fill. Actually this is very simple. Okay, the first value xy is calculated. Okay, then what is z bar? So complement of z, you see you have in column 3, this is column 3, in column 3 you have all values of z. Now what you write here, z bar, which means the complement of z. So here if z is 1, the complement is 0. If z is 0, complement is 1. Like that you have to fill this column. Okay, now what you do, xy plus z bar, which means now you have to add these two columns. Okay, this plus. Okay, add these two columns. Okay, so now that is your final answer. So 1 plus 0 1, see 0 plus 0 0, like that you have to fill the final column. So this is called column 6. 1 2 3 4 5. Column 6 is nothing but all values of the given Boolean function. This is what we require in the question. Okay, that's it. Now we'll see here another example. Prove that x dot y plus z equal to x dot y plus x dot z. Okay, what is given? Use truth table technique to prove this Boolean expression. Okay, so now you take LHS and RHS. We have to calculate both values by truth table. Then we have to check whether both are correct, both are equal, both are equivalent. Then we can confirm that, we can conclude that this is the right expression. Okay, now here you see how many variables, x, y is a 3 variables, so that I can list 8 different 3 tuples. Okay, 8 different 3 tuples. Okay, that's what here. So 1 2 3 4 5 6 7 8. Okay, now you see here in LHS, x multiply y plus z. So first you have to find y plus z. Yes, that's what we are doing. Okay, then x multiply, so that see this and this you multiply. Okay, then you list all the possible values. Okay, now what do you want in the right side? So first you multiply x and y. Okay, so x and y, this you do. So for that I put star. First you do x and y to multiply. Okay, this is here. Okay, next x and z, so that this I can put 2t, x and z. Okay, I multiply. Okay, finally what we have to do, xy plus xz, these two you have to add. You have to add these two columns. Okay, so now xy plus xz. Okay, this is the right side value. See, that's why these two columns in different colors. See, column 5 and column 8, different colors, means red color. Okay, so this is your left side value, this is your left side value LHS, this is your right hand side value, what is given in the question. Okay, so now you see both are correct, both values are correct in each row. See here 0, see for this different combination, for this combination, or for this particular combination, here 0, here 0. Okay, so equal. For this combination, here 0, here 0. Similarly, you can check each and every row. So now we checked what is that LHS equal to RHS. So that this is true. This expression is true. Through truth table we have proved. That's it. We will see the continuation of this lecture in the next video. Thank you.